Hello everyone and welcome to Mathematics, where this channel is able to help you to build out your habit in completing a question a day in mathematics. So for today's video, we will look at a question from Book 5 Chapter 2, Differentiation. So before we begin, you can take a look and try it by yourself first. So what we can highlight from part A, which is these two things. So first I will introduce the three levels in differentiation. The first level would be y, which represents equation of a curve. So example is this. So if we differentiate y, we will get the second layer, which is dy over dx. So this helps us to find gradient of a tangent. So example, if I draw a curve and I draw a point here and I draw a line to pass through this point, this line would be the tangent. So dy dx helps us to find the gradient of this tangent. So there's another name for it, which is the first order differentiation. So you just need to differentiate one time to get dy over dx. So if we differentiate dy dx again, you will get the third layer, which is d square y over dx square. So this helps us to find the minimum or maximum point. And there's another name for it, which is the second order differentiation. So we need to differentiate twice to get this. Back to question A, if we need to find these two things, the maximum times we need to differentiate is 2 times. Right, so before we differentiate, let's expand this equation first. So now, before we differentiate, we need to separate the equation using positive and negative. So meaning, I can split this equation into 4 parts. And I differentiate part by part. So for this value, I would multiply the number of x, which is 4, and its power. So 4 times 3. And we minus 1 from the power. So we'll get 2. So same goes to this. We multiply the number and the power together, which is negative 24. And we minus 1 from the power. We can use the same way for 9x as well, but if shortcut, you can just remove the x. And for negative 4, if we differentiate number, it will become 0, so we can just ignore. So let's differentiate again to get the second order differentiation equation. So again, separate by the positive and minus. And here we multiply the number and the power. And power, we minus 1 to get x only. This one, we just remove the x. So here we obtain our 2 equations. So you all may be wondering, teacher, can I use product rule to differentiate this equation? Okay, actually you can, but let me show you the working for product rule. So it will be a bit complicated because we need to separate the x and 2x minus 3 power of 2 to differentiate separately and then combine it together. So it will involve a lot of computation and will have a higher risk of doing some careless mistakes. So what I suggest is, since this equation is not too hard to expand, so I would advise the students to expand first and then to differentiate. So it will be much easier and straightforward. Alright, moving on to part B, hence. So hence meaning we need to use the answer from part A and to apply it in part B. And we need to find the coordinates of the turning points, and from those turning points we need to find which is the maximum and which is the minimum point. So what are turning points? So turning points, there are actually only 2 types. One is the minimum point and one is the maximum point. So how do we find the turning points first? So we can use a concept which is dy dx equals to 0. Okay, reason is because if I draw a curve here, and this is its minimum point, and if I draw a tangent across this minimum point, you can see that the gradient of the tangent is 0. So since gradient of a tangent also represents dy over dx, so we can also say that dy over dx is equal to 0. So this is how we are going to find the turning points. And how do we differentiate turning points with minimum point and maximum point? So here we can use the second order differentiation value. So if it's d square y over dx square is more than 0, it will be the minimum point. The maximum point would be the other case, which is less than 0. So let's try to find the turning points first. We can use the equation from part A and to sub 0 into dy over dx. And we simplify it. And we can use the calculator to factorize this quadratic equation. And you will get x equals to 1 over 2 and x equals to 3 over 2. So we are going to find the coordinates, we need to find the y value as well. So to find the y value, we can use the original equation, which is on top here. So by subbing in the x value into the equation, we will get 2 points, which is 1 over 2 and negative 2, and the other point would be 3 over 2, negative 4. And now we can determine whether these points are maximum or minimum. So we can use the equation from part A. And sub the x with 1 over 2. And you will obtain negative 12, which is less than 0. So this is a maximum point. Same goes to the other point. Since 12 is a positive number, hence this is a minimum point. So we can do a final conclusion at the bottom. And with that, we have completed this question. So this question, it involves one of the applications in differentiation, which is this. So this part helps us to focus to find turning points and to see whether the turning points are minimum or maximum, which is the take-home point for this video. So turning points, there are two cases. One is the maximum point and one is the minimum point. So how do we differentiate? We use the second order differentiation value. So if it's less than 0, it will be max. More than 0, it will be minimum. So if you are interested in this question's answer scheme, you all can refer to the link in the video description, and you feel this is beneficial to you, you all can like, subscribe, and share to your friends and classmates. And if you have any questions regarding this video, feel free to comment. Right, so I'll see y'all in the next video. Thank you.